So I'm going to make 3 columns here. We're going to list physical state of the solution itself in the first column. We're going to list the physical state of the solute in the second column. And the last column is going to be examples and explanations. No? Okay, so let's start with solutions whose physical state is gas. Okay? And I want to talk about some examples and explanations of gas solutions where gas is being dissolved in gas. So the physical state of the solute, the thing being dissolved, is also a gas in these examples. Okay? So one example is air. Okay, in air, the gas that is in the highest concentration is nitrogen. So nitrogen is the solvent. Yes. Sure. Okay. And all other gases are solutes. So what other gases are there in the air besides nitrogen? Hydrogen, oxygen. Okay, well, hurry back. We got a lot of notes to take. Okay. Okay. There's helium in the atmosphere. Carbon dioxide in the atmosphere. Okay. And when you sign in, just put that in your personal file, please. Thanks. Okay. So that's a really simple sort of explanation of gases dissolved in gases. You can dissolve just about any gas in another gas. There are some rare cases where you have very dense gases that won't dissolve in other gases very easily, but almost any gas will dissolve in another gas. Okay? Alright, here's an example of a liquid dissolved in gas. So in the air, everywhere, there's a certain amount of water dissolved in there. That's from evaporation. So water dissolved in air is an example of a liquid dissolved in a gas. What? Class rulers? I occasionally give you guys rulers to use, but I'm not going to give them out as a matter of course. I'm not going to give them out on a regular basis. Okay, so if we have a liquid solution, we can dissolve gases and liquids and solids in liquids. Okay, so some examples of gases dissolved in liquids would include carbon dioxide, dissolved in the water, that is the solvent in soft drinks. That's an example of a gas dissolved in a liquid. There are household cleaners, and if you go to the store and you buy a household cleaner that says ammonia, well, ammonia itself is a gas, and what they do is they dissolve that ammonia gas in water, and so ammonia cleaners are ammonia gas dissolved in water. If you go to any hardware store and buy something called muriatic acid, muriatic acid is a gas dissolved in water, and muriatic acid, we call it in a chemistry lab, we'll call it hydrochloric acid, HCl, hydrochloric acid.
Can't you use that to clean concrete?
That's exactly what it's used for. Okay, let's put the food away. We're not supposed to eat in here, okay? Okay, so that's in fact you find it in the construction section because it is used for that purpose, usually around the concrete products. Okay, so we can dissolve liquids in liquids. And some examples of those would include alcoholic beverages. Okay, these are examples of, it can be either water dissolved in alcohol or alcohol dissolved in water depending on the concentration of the two. So it's, in any event, it's alcohol and water. And determining which one of those is the solvent and which one is the solute depends on which one you have the most of. Let's see, rubbing alcohol. That's isopropyl alcohol. So if you go to a department store, the drug store, or even a grocery store, you can buy rubbing alcohol in one of two concentrations. One is, I think, 73%, one's 91%. And what that means is that if you do the percent mass calculations, you have 71% isopropyl alcohol and that could be 29% water. Okay, but that's an example of a liquid dissolved in a liquid. Okay, and then we can come up with an example of many examples of solids dissolved in liquids. So when you put sugar in your tea, that's a solution. Sugar dissolved in water. Well, sugar is a solid. Tea is mostly water. When you put sugar in water, you've got a solution where solids dissolved in a liquid. How many of you have ever been told to gargle with salt water when you got a sore throat? Okay, that's a solution. Table salt dissolved in water. So table salt's ionic. It breaks up into separate ions. Sugar's not ionic, but it breaks up into separate molecules in the water. We talked about how you solvate those, I think yesterday. There's an O right here I'm missing out of alcoholic beverages. Okay, I think that's enough examples of solids. Just do one or two so you can kind of hopefully relate some of these more complex concepts to everyday materials. And then you've got lots of solids that are solutions. Lots of solids that are solutions. Now, you can dissolve gases in solids, but it's kind of rare. It doesn't happen very often. One process that may be a lot more prominent in the future, in the near future, would be hydrogen fuel cells. You can run your household electrical appliances with hydrogen fuel cells. You can run cars on hydrogen fuel cells. But you have to be able to store the hydrogen in a way that it's relatively safe, because hydrogen is a very volatile gas. And so what you do is, hydrogen fuel cells, what you do is you dissolve, one way to do it, there's many ways to do it, one way to do that is to dissolve the hydrogen, which is H2, in platinum, which is a metal. It's an elemental metal, physical elemental symbol PT. PT for platinum, that's the elemental symbol for platinum. Okay, liquids dissolved in solids. There are hydrocarbons, substances that are solid. We talked about how hydrocarbons, you get them really, really long chain hydrocarbons, they're solids, and sort of middle range chains you get liquids, and short chains you get gases. Well, if I take a mid-range hydrocarbon like hexane, I can dissolve that into a substance that has a really long hydrocarbon chain, like something that's commonly called paraffin or candle wax. And so the resulting solution is a solid, but it has a liquid dissolved in it. It's not used so commonly anymore, but they used to dissolve mercury, which is a liquid metal, in a tooth filling. Okay, so you got a cavity in your tooth, they fill it with this material that had mercury in it. So, you know, those gold fillings that you see people with sometimes, a lot of those used to, I don't know if they still do, have mercury in them.
I thought mercury was poisonous.
mercury salts or mercury ions are poisonous. They are. And that stuff is pretty stable, so it's not going to get in your bloodstream, but I think that's one of the reasons they don't use it anymore. I don't know that for a fact. I'm not a dentist, but that I would assume that would be the case.
I'm a dentist.
Okay.
Oh.
All right, so there's lots of examples of solids dissolved in solids.
Can you slide it up?
Mm-hmm. Steel is a common example of a solid dissolved in a solid. Regular steel is carbon dissolved in iron. Stainless steel has chromium dissolved in the steel in addition to that carbon. There are lots of different kinds of steel, all of them with different properties, and they have different things that are dissolved in there to get those different properties. If you're going to make a drive shaft, you have to have certain metals dissolved in the iron to make it really, really hard so it doesn't expand under heat. Okay? You don't want it to bend. You want it very, very stable and dense. So there's lots of kinds of steel with different things in there. Brass.
So, Mr. Tuttle,
I'm sorry, there should be some. Yes.
what's going to be on the test?
This is going to be on the test.
What test?
So we're not going to have to work nothing out?
Yes, I have one more thing to do that, and we're going to get to that shortly. The test tomorrow. Okay.
Oh, yeah, I made mine on the last.
Made 100.
So brass is an example of solids dissolved in solids. Brass is a mixture. When you dissolve one metal in another, it's called an alloy. And it's a mixture of zinc and copper.
So that's what they say when they say alloy lives?
Yeah, alloy. Yeah, I don't know why they say it that way because there's so many alloys out there. It's almost like the term doesn't mean much, but because we talk about different kinds of steel. You dissolve chromium in iron, that's a form of steel. Well, that's an alloy. That's just stainless steel. You got stainless steel flatware, that you use to eat with. That's an alloy. You got alloy spoons. So I don't know. I guess it just sounds good or something. I'm sure there's something special about what the term came from, but just the term alloy doesn't mean much. There are so many alloys, it's practically, superfluous. Okay. Any questions about that? Unnecessary, more than enough. All right. You guys want to stretch a minute and get a drink of water? Yes, you can go to the bathroom. No nap times. Sorry. Stretch, wake up. So we're going to wake up, we're going to pay attention, or you're going to be standing at a lab table. So.